So in continuation to our last discussion, we'll consider instantaneous type process, and one of example we discussed with that how to model. Some other examples, like another case is the integral process, okay, which typically we can define by this particular statement of anything related to the first derivative of the output of your response is the first derivative of to the input. Okay? So for example, you heard about CAD system? CAD is primarily begin with the mechanical platform. So when you say CAD, by default it represents the mechanical or physical engineering, clear form of engineering. Then we have an electrical CAD also. Okay, almost two and a half decade back, it has been started. So they add some other element value through which you can have a dynamic modeling of an equivalent electrical network or electrical device. So now you have a platform like RSCAD. RSCAD means RS here short term stands for real time simulation. Okay. CAD is computer aided design. Okay. So the RSCAD, or when you talk about nowadays the almost from within the past 2 decades, some of new platform has been introduced like RTDS, that is real time digital simulator. Yeah, you can have the kind of simulation if you as good as the real-time response, because when you do some simulation on MATLAB and Simulink platform, it's like a, you can say, ideal environment where you do not consider certain influential parameters like the noise, the interference of the signal, interference of unwanted signal. So because of that, whatever response you are getting, that may not be effectively applicable in a real life situation. Getting my point? So when you perform an experiment, when you perform a MATLAB simulation, there may be a difference in results. Clear? Sometimes error could be 10%, 20%, even more than 20% also, which is not acceptable. Okay? On the other hand, these platforms like RTDS, there is a company also, so don't be confused. Yeah. So these RTDS platforms worldwide introduced by so many popular platforms like Platform Hill, like you can say we have one of such platform here, RTDS and all these things. Then we call it Agile. Agile stands for hardware in loop. Okay? PHIL stands for power hardware in loop. So basically P stands for specific application related to power systems, because you are dealing with the high voltage environment, high voltage and high current environment. so that it is called PHIL. So typically these terminologies, these platforms are specially designed to simulate anything related to power stations, power grid, overall power system network, okay, and the results you will get from these kind of platform have a nearly the similar impact, sometimes 100% impact, the same as you are going to perform a experimentation and how the grid will visualize it, how the grid will react upon it, right? Because you know that in a real life situation, these power stations grid are very costly affairs, extremely complex in nature, in nature. So you cannot all the time develop a prototype algorithm and test it over the actual grid. Okay, understand? So to save your money and to get optimal efficiencies, we try to follow these kind of platform, RTDS platforms, real-time digital simulation platforms. Clear? Opal RT is another example. Opal RT is a company. Okay? RTDS is a company. Dicom is a company. Okay? But all it provides this real-time digital simulation. Clear? So these all are the category of integral process. First order system, we have been already seen. Okay, many of the circuits like RL or RC circuits, number of times you have considered. So that is the electrical equivalent network. In real life situation, for example, you can take an example of thermometers. Okay, you are measuring the temperature. What is the example of that? That's the first order system. Okay, so the behavior of the first order system, you know. Here the point we wanted to notify that at time tau, this is the standard equation. So at time tau, we are getting almost 63% of the magnitude. Okay, if 1 is the optimal value, so we can have 63% of the total or optimal magnitude. If 63% is magnitude, that means the percentage of information you are able to occupy. What are the rest then? 1 minus 0.63. What do you think? Doesn't matter whatever conversion mechanism, sensing mechanism, control mechanism, communication system you develop, you always want to have your 100% of the information. Yes or no? Yeah? So if at time tau, this equation is correct, any correction is needed, standard equation, right? So that is a steady state condition, y infinite, y t is the instantaneous value. Okay. If t is equal to tau, now tau is known for any linear circuit, tau is known. So if t is equal to tau, then this value you are getting 0.632. We know it 100 times. What does it mean? Because your system is centered somewhere here, na? This dash line is represented. So this dash line is a reference or is your set point. What you want to achieve. Clear? Now, because what will happen that ideally this curve should perform like this, a perfectly straight line. Okay. Now practically that is not possible because of the nature of this equation. Okay. So you are going to attain this particular curve. Check. So in that particular scenario, once you are trying to reach a state condition. So this is something I can treat it as a transient. So in the transient duration at time tau, the magnitude is 63.2%. So what are the rest? Noise. Because nothing is vacuum. In a real life situation, your medium is not vacuum. Right? Clear? Though permittivity of air and vacuum we consider the same mathematically, but in the real life environment it is not a vacuum. So if it is the air, if your insulation medium is other than vacuum, that means there are possibilities that certain other signals may arise or may exist at the same time on available at during the same bandwidth, or in fact operating at the same frequency. Possible? Possible, na? all of our cellular message is operating at the same frequency. Okay, operator to operator there may be slight deviation, right now. But if something is operating at megahertz, so that is also operating at megahertz. It's not like that one operator is operating at gigahertz, another is operating at megahertz, another is operating at terahertz. Is it like that? No. There is a deviation in operating frequency. Possible that one may operate at 1 megahertz, another is operating at 1.5 megahertz, another is operating at 2 megahertz. How do you able to detect it? Because this 1 is fixed, 1.5 is fixed, 2 is fixed. So if I can tune my radio, tuning signal, my tuning circuit at 2, so it will pick only particular signal, not which one is available at 1.5. Is it correct? Any deviation in discussion? Okay. So now as the time is kept on passing, what is happening? It is trying to approach to 1. We know that it will never reach to 1. Okay. Or it will take infinite time to reach 1. That is something I can't avoid. Clear? So if I am providing infinite time, means bandwidth should be 0. So at 0 hertz you cannot operate. It's as simple as that. Correct? So you need to compromise with that tolerance. That is not our issue. Now point is that what should be your tolerance band so that you will be able to recover your signal in a healthy way, in a factful way, so that your signal to noise ratio should be acceptable. Okay? So you know that we follow 2 criteria for commercial application: 5% tolerance, 2% tolerance. Depending on your situation, if you are adopting 5% tolerance, so your system will settle little faster as compared to 2% tolerance. Remember, na? Let's say somewhere here is 5%. So 2% will be later to that. Getting my point? This idea is clear? 5% means with respect to this reference, variation is plus minus 5. 2% means with respect to this reference, variation is plus minus 2. So which one comes first? 5% tolerance, because it is allow you little bit more tolerance. Okay, nearly 150% more than 2%. Correct? So if you are comfortable, if your application is comfortable with 5% tolerance, obviously system will settle fast, relatively faster as compared to 2%. But in 2%, signal to noise ratio will be much better than 5% rating, because the chances of error is maximum is 2%. Here chances of error maximum is 5%. Okay, so 5% is plus minus 2.5. 2% is plus minus 1%. Okay, so band will be. So obviously your system will settle first. Right? Now rest you know that how we can linearize it even if it is a non-linear system. Yeah. So all these examples, what you have seen, that comes under first order system. Now the most popular second order system. Mathematically, we already have studied under the head of network theory, so it's nothing new. So I am not going to discuss again the mathematics, but there are a slight change. Till now, under the head of your mathematics subject, when you take or the circuit analysis or device engineering, whenever you study, you probably consider a second order system like x square plus bx plus c is equal to 0. Is it? Where a, b, c are some coefficients. Correct? So that we can rectify. Okay? Order of equation is 2. So obviously it will offer you maximum 2 acceptable roots of the characteristic equation based on the value of and the type of those pair of roots. The characteristic of the system will react upon it. If there are 2 real roots, characteristic will be different. If it is a complex conjugate pair of root, then the characteristic will be different. Is it clear? Based on that, we might have seen that because it is a second order system, so if there is a damping, if the damping is one of the factor, then based on damping we can further classify in 3 categories, 3 acceptable categories I would say: overdamped, critically damped, underdamped. Because in undamped there is a no damp, right? So undamped means your sigma, that means your attenuation or your resistive component is already 0. So if it is 0, that means if something is operating at 1 megahertz, so it will keep on operating at 1 megahertz until unless it is not de-energized. Correct now? Okay. Now there are three things we have been already discussed, that there may be a certain specific application or exceptional applications of overdamped system also. Critically damped is something idealistic. Everybody wish for, है ना, a fantastic life without any effort, without any work, to be a billionaire, है ना. Everything should be available on the doorstep, and the generations need not to do anything. Right? Happy? Feeling happy? है ना? How would you react with the billion rupees, 1 billion rupee? Not 10 billion, 1 trillion in pocket. Now feel. So HG generation is more enthusiastic. If you ask my generation 1 billion, heart attack हो जाएगा शायद, आदमी चला जाएगा, नहीं? Good to expect 1 trillion. Okay, imagine 1 trillion, right? So will it ever happen? हाँ जी, होगा क्या? अरे will it ever happen? Without doing anything, sit back at home, don't do. Not only you, your generations decided that we are not going to do anything. 1, 2, 3, 4 generations, है ना? Wait for a day, wait for a moment, है ना? Some will come and reward you 1 trillion rupee. नहीं होगा तो क्रिटिकली डैम्ड में नहीं मिलेगा. ठीक है? क्यों नहीं मिलेगा? क्या बोले? Forget. How can I get a critically damped? Let's say this is the same reference I am using. Forget the first order system. So that was our reference, na? 100%, right? Na? So if it is a critically damped, then what will happen? You are somewhere here, है ना? So with no time, I should be able to attain this characteristic. है ना? What is the rate of change? Infinite. And then again I have to attain one more rate of change, because this is the same, right? Huh? So if there is a no time, so with no time I should reach from this point to this point, है ना? And then of course within no time I should be able to attain this characteristic. Okay? So zero rate of change, infinite rate of change, zero rate of change. ठीक है? With reference to this origin. Correct? Possible? Possible? Eh? Possible or not? Eh? Not possible. है ना? How can you make it possible? How can we make it possible? Or why is it not possible? You heard about point of singularity? Singularity point. Just revise it. Happy. Huh? Point of singularity. Okay. For example, practically get not done. You are passing through a black hole and you are able to come out. Light is not able to come out, but this genius guy is able to come out. Entire class is genius, including you. ठीक है? Will it be possible? Theoretically? Forget about practical. Theoretically? Yet not possible. ठीक है? So if you can achieve mathematically the point of singularity, you can achieve this infinite rate of change. I said that with no time. So no time means no time, not t. Your tau is tending to 0. Tau is a small portion of t, right now? Okay, a pocket of instantaneous time. So within that pocket, now tau is stretching to 0. Rather, I would say that compressing to 0. Okay? So with no time absolutely, you are trying to achieve the infinite rate of change. Okay? So this is the problem. So the same problem persists even your order system is changed. Remember this, okay? Now, obviously, it is the most widely utilized system. Electrical systems you have seen, order of system. These are certain examples, but not limited. Vibration sensor, you heard about it? Heard about it? It's the second order system. Accelerometers, है ना? कहाँ लगा है? Vehicle you drive, right? Okay, it has an inbuilt accelerometer now. Earlier, some mechanical option was there. Now there is a smart sensor is already embedded inside. Okay, so it's an accelerometer. Anything else? So many examples. Okay, some physical, like there are two tanks. There are multiple tanks, overhead tanks. Okay, installed over the rooftop of your hostels. Correct? To ensure the proper supply of water. Right? Maybe one tank insufficient, so that they calculate your daily consumptions and average consumption. They see that the number of users, then if one tank capacity is this much, then how many tanks of same size will be needed to entertain the users for 24/7. So that's how they install number of overhead water tanks. Yes or no? Okay. So now if two or more than two tanks are connected in series, that is an example of a second order system. Correct? So you can very well calculate that if this is the rate of flow of water, how much time it will take to be filled or to be empty if you are consuming in either. Yeah? So that is it. But now there is a difference. There is a difference you see. So here remember, this is representing one mass spring damper system. मास स्प्रिंग टेम्पर सिस्टम में पढ़ा होगा, मैकेनिक्स में थोड़ा सा पढ़ा होगा, हाँ? नहीं, हाँ, इनके कहीं तो चौड़े हो गए ना. Inter science you have been studied, you have come through, है ना? Even in escape rate project, double purpose, again in mechanics you have studied, yeah? Second order system में पढ़ा होगा, everything doesn't matter in mechanics study हो, maybe तुमने mechanics से नहीं पढ़ा, तो let me accept, okay? Mass you understand, है ना? Mass of your transducer, है ना? Your mass, your body mass, है ना? You are using automobile, its body mass, right? Mass of this pen, mass of this smart display, and so and so. Damper you understand? Damping mechanism, suspension. So suspension is basically the spring. Okay? So it will provide you stiffness. One will entertain to bear the stress applying over the body, and another is providing you to entertain the force against the friction. So that is called stiffness. Okay? So there are three terms: mass, spring, damper. Okay? Now remember that some of the authors they may use rather than capital B, they may use a small f as a terminology. These are the standard terminology acceptable worldwide. Okay? To realize any form of physical or electrical engineering. Here, so here for our reference, I am taking M, V, K as a three terminologies, out of which K represents the zero order statement. Okay? So whatever the input or output to this particular component you are experiencing, it will always respond you at zero order. Okay? So if x is the input, x is the displacement, then you will get the response k time of x. Get my point? Without change order. Now if you are providing the same input at same time to this friction, okay, this damping mechanism, then this will give you first order response. X is the input, so now you will get dx by dt. Get my point? So it is a primarily first order system. Can we say it? Now at the same time, if there is a mass of that particular subject or object where you are applying that force or pressure or displacement, in that case the mass will always respond to you at the second order. Okay? These all are already proven. We are not to do any new engineering solutions. Clear? So if x is the input to M, So through m you will get the response of second derivative of x. Getting my point? So this response, because of m you will get second order, because of b or f, okay, either people write it small f or capital B, use one of the symbolic representation. So this is your fraction, you will get x dot if x is the input, and here you will get 0 order, okay, k time of x. Done? Now let's see, this is the arrangement. Okay, we will exercise. Rather, I would suggest you now that because I have taken one of the case studies, so while we are discussing to develop the better understanding, parallelly you draw it and you should practice it rather than just see it. Okay? Otherwise, unnecessarily you will be confused while you will be examining. Okay? Do it so that your this part of brain will have a habit. Okay? Now that is the drawback of presentation. I'm telling you. Okay? Something you kept on writing, your memory understands in a better way. Okay? Rather than just kept on watching it. So whenever you have some opportunity, use it. Otherwise, these notes are already available to you. Okay? Now tell me. Now, when we consider general second order system, how do we write? If x is the input, then mx square plus bx plus bx, okay, plus k x raised to 0 is equal to 0. That is how you write. Right now, right hand side is normally 0 of any characteristic equation. Now here you are not going to do. Here you are not going to do that. Okay? Because this right half section will be always a non-zero value. Why so? Because now you are considering a practical scenario where you are feeding some input, and with respect to that input cause you are expecting some response. Anything new? This idea is clear. I am providing some input to a system. That system is a second order system. So obviously I am expecting some output because it is a second order system that I know well in advance. So obviously the output response will be also second in order. The highest order should be second in order. Understand? If no further integrator or differentiator are inbuilt through along with this device. If this is a pure circuit, physical circuit or electrical circuit that has second order, so whatever input I will feed, output I must get at a second order. Idea is clear? If I will integrate one more integrator around this, what will happen? The original output will pass through integrator, right? So that means the output response now should be first order, right now. But if a differentiator is added here, okay, so digital differentiator circuit, then the order should again enhance. If order is again enhancing, non-linearity is adding, right? But the output will be more sensitive, faster. You will get faster response at the cost of non-linearity. Integrator circuit, you are trying to more linearize. You are trying to sum it. So you have taken some feedback, compare it. Now you see that I need to reduce the order. So you have reduced it. So any third order is reduced to second order system reduced to first order. So that means you are trying to linearize it. But because of this process, your system will become sluggish. Okay? So these things mathematically you will study under the head of control system. There is no more mind. So whenever you pass through an integrator, you are trying to linearize the system. System response better ho jayega. Because anything is linear is more predictable. Okay? But because of this summation process, it will always take some time. See, the one process integration is what? Is summation. Differentiator is what? Rate of change. Rate of change, na? So which one will be faster? Rate of change. Okay? Which one will be slower? Summation process. Summation process is reducing the order. So obviously increasing the predictability, enhancing the linearity. On the other hand, differentiator is enhancing the non-linearity. Okay? So now you decide whether you want a fast response or whether you want a predictable response. You want a stable response. Okay? Getting my point? Idea is very well clear. तो बैठे बैठे 1 ट्रिलियन रुपीस नहीं मिलेगा, मिलेगा नहीं मिलेगा. ठीक है? उस दिन तुम पॉइंट ऑफ सिंगुलैरिटी को भी अचीव कर लोगे, उस दिन तुम रेट ऑफ चेंज को भी, इनफाइनाइट रेट ऑफ चेंज को भी अचीव कर लोगे, ठीक है। उस दिन तुम विद नो टाइम यहाँ से स्वर्गलोक पहुँच जाओगे, विद नो टाइम तुम स्वर्गलोक से और कोई लोक में पहुँच जाओगे, ठीक है। विद नो टाइम वहाँ से तुम यहाँ पे आ जाओगे, ठीक है। अभी तुम 20 एज के थे, तब भी तुम 20 पे ही रहोगे, बिकॉज यू हैव अचीव पॉइंट ऑफ सिंगुलैरिटी। Basically, your notes are comparable. Now you see here, what is in the right hand side? Some non-zero value. So remember this. Here it is a platform. It is a platform. So remember this is entirely semiconductor device. I am talking about a mass spring damper system of semiconductor type of mass spring damper system, whose overall weight is some around 10-12 grams. That's all. Probably is 10-12 gram is sometimes is very heavy weight. Okay? Not in half of the kg size. So it's a small in diameter of millimeter size. Okay? So now here is a mass, here is a suspension, here is a damping mechanism to avoid the frictions or to deal with the friction. So everything is suspended over this plane. Here now I have to keep protected it from the environment. So I will use a casing, steel or any industry standard casing, so that external environment should not hamper it, should not interfere. Understand? Because when it will operate at a particular frequency. So if external environment is able to interfere, then what will happen? Frequency mixing हो जाएगा easily, ठीक है? So you are going to use a particular kind of material as a protection shield, so that external signal should not be easily interfere with the inside mechanism. ठीक है? So अभी हम इसको क्या करते हैं, सीलिंग कर देते हैं like this. Getting my point? Now here is some xi, you can see. So let me see, xi is the displacement. अभी वो xi कैसे मिला? So this device is suspended over here. If some force will apply from a particular direction, let's say from downward direction, let's say, ठीक है? So this force or pressure will be ultimately can be converted to displacement or not? Yes. So let's say that measurable displacement is xi, input displacement. I stands for input, nothing else. ठीक है? So let's say that amount of displacement can be measured by xi, maybe centimeter, meter, millimeter, whatever your dimension is. You follow? ठीक है? Now, if this side you are getting some displacement, if this body is experiencing some displacement, what will happen? It will try to move up. Correct? Now you see, there is a lead or rope which is connected here, and the other side of the lead is connected at here. Clear? है ना? Pair of like electrodes. So this is not electrode, but two connecting points. ठीक है? May or may not be electrodes. ठीक? So here you are getting one end, here you are getting one. Now whenever this mass spring damper mechanism will experience certain force in a particular direction, this will change or not? Yes? Either it will compress, experience some compression or expansion. Okay? So that means you will get some x here. So that is the resultant displacement experienced by this entire setup, this mass spring damper mechanism. Okay? So let's say that one is x naught, output displacement. Getting my point? So अभी तुमने क्या बोला था? If x is the input, this part of the system will experience in the same order. This part of the system will experience in first order. This part of the system will experience in second order. All comprises of one device, one system. So you will get this plus this plus this, right? So can I say that mx naught double derivative plus vx naught single derivative plus kx naught same order, है ना? Is equal to, you are getting this response because of this input displacement or not? If input displacement is 0, then within definite time, within few milliseconds, microseconds, your x naught will also tends to 0. If x naught is tends to 0, there is no left hand side. So now the right hand side is not a 0, it's a non-zero. Okay? Probably this is the first change you saw in your engineering solutions. Right? you may or may not have solved, and even if you have solved in mathematics subject, now you recall that mathematical problem was connected to such kind of application. Getting my point? Sometimes you might have considered that right hand side is non-zero value. If it is a non-zero value, that means it will give you a non-homogeneous solution. Yes or no? Huh? So this is the realization. So here we are getting mxi double. क्यों? मास को पुश किया था ना तुमने, है ना? You apply the displacement over the mass na of entire body. So it has a certain mass or not? Okay. So let us. I am assuming here that the additional shield or encapsulation used to protect your device has very negligible amount of mass. If the mass of an actual system is, let's say, 10 gram, then the shield's mass is, let's say, less than 1 gram. So probably for my easy calculation I can avoid. For correct calculation I can add 10 plus 1 gram. For easy calculation I can avoid that less than 1 gram and I can treat it as 10 gram. Okay? So this is as well as the same mass. Getting my point? So now right hand side is mxi double. Now can you solve this and find out your transfer equation, transfer function in S domain, of course. Don't solve now on time domain. Solve it on the frequency plane so that you will be easily get. Okay? Now you see here this response you are getting. X naught S upon xi is equal to ms square upon ms square plus bs plus a. So you can name something. Yeah? Equation number 1, equation number 2 for your better understanding. Is it clear? Are we clear about it? Right? Now tell me another thing, very important. What is this left hand side? Transfer function or maybe gain of the system? If it is amplifier, gain of the system, in general, it can be impedance function, it can be admittance function, it can be some transfer function, some network function. है ना? ठीक है? है ना? Clear? Now tell me this xi or x naught is a relative or absolute? Xi is a some value, some information. X naught is also some information. Maybe the same state of energy could be different. Okay? Maybe both of the state of energy could be the same. It is a sum ratio x naught by xi. I don't know. Maybe xi is a physical input, x naught is an electrical output. Okay? Or till now I have not converted to electrical. So xi, like for example force, x naught is a displacement. Both are still physical in nature. Both are still mechanical in nature. Ajit, are we clear? Huh? नहीं, remember you are designing this vibration sensor, accelerometer, ultimately. ठीक है? So need to understand each and every step. ठीक है? So this x naught. Now my question is, this x naught or xi is relative in nature or is absolute in nature? Let's say xi is basically 5 centimeters. Unit is centimeter. 5 is the magnitude. So total distance you recover is 5 centimeter or 5 meter. Now when I say 5 centimeter, 5 meter, it is a relative information or it is a absolute information? बताओ भाई. Relative? Correct. Why relative? Why not absolute? We are measuring from a reference now, and a reference point could be changed. 0 to 5 is also 5. 1 to 6 is also 5. I do not know what was your reference point. Right? So input has a reference point. Output will also have a reference point, even you have converted it or not. one form of energy into another form or in the same form of energy. Both will have a difference. So it's actually relative input, relative output. Is it? Eh? Is it? So that is something we have seen till now. Whether we consider Fourier or Laplace transformation, whether we consider a transfer function on a time domain, whether we consider a transfer function on a frequency domain. Is it correct till now? Likewise here, we notice one difference. Because it is a real life scenario, we have just seen that right half section is not zero, it's some non-zero value. And of course it has to be some non-zero value. Without a non-zero input, you cannot get a measurable output. Simple. Okay? Now there is a second point. How the nature responds to information available in absolute form or relative? Just get on C and give me a signal. 2 minutes. Okay. Fine. Okay. Now my second question. Because this force is a some natural signal. Na? Natural means it can be man-made physical signal usually. Okay? Now how does nature reacts with you or exchange the information with you? In absolute form or in relative form? Relative form. Okay. How do you know? ये याद रखना है. Nature always respond to you in absolute form. It doesn't matter what kind of information across the world. Okay? On this earth. Every information is available in absolute. Your measurable, detectable, analyzer, controller works on relative scale. And because of your own flexibility, because of our own flexibility, we want to display that data in a form as a human we can appreciate it and understand it. We want to process this data so that we can automatically take certain decisions. Okay? We want to store this data maybe for future reference purpose. Okay? At the same time, we are analyzing the data using some kind of analog or digital processor. Probably you wanted to do all these tasks at the same time. Display, memorization, analysis, everything you want to do. Okay? So your man-made mechanism, primarily all this sensing and signal conditioning. There are two major domains while you are converting this information. One is the sensing. आपने sense किया. Okay? So because now you have a nano devices, we primarily called it micro machining or nano machining. Heard about it? Eh? So this is one part of technology. Okay? Simpler language, you can say that this is the most advanced field of mechanical engineering. Okay? You heard about microelectronics? It was during my age. It was the most modern subject. Now you have a nanotechnology. Right? Now forget about that now. Factor is 10 to minus 9. Scale could be 1, 10, 100. Just forget. Okay? Factor is 10 to minus 9. Okay? So this nanoelectronics, microelectronics is one of the advanced field of electronics. What do you do? What do you do with this field? You try to develop a signal conditioning circuit so that it will be able to respond to you within no time, within the measurable time, with its optimal characteristic. Highest possible resolution, most accurate, highest signal to noise ratio, very accurate, should be able to reproducible. That means अगर मैं उस watch को 10,000 times भी use करना चाहता हूँ तो it should respond with the same reference, same time. Okay? In mechanical watches you might have observed that after certain years it impacts some aging effect. Why? Because that movable part is some mechanical body. It has a certain weight. As compared to that, if I am trying to display the digit, binary digit, then it has almost no weight. Right? So obviously aging effect will be much lesser. I won't say zero, but much lesser than as compared to a mechanical watch. Clear? So remember that this right now, this mathematical reference is relative input and relative output. Now the problem is your input जो तुमने force apply किया था, that force was absolute in nature. Understand? Now what you will do? कोई तरीका है? Is there any way by which, by playing with this existing transfer function, I can get that what I want? What we want? Relative form of information. Okay? What is available? Absolute form. So we need a mechanism, right? What do you do? Which one is the independent domain? This one? Shift this to here. Shift this to here. So remodify your transfer function. Rather than xi, x naught by xi, you write it x naught by s square xi. Why s square? Because remember it's a second order system. Right? If it would be on a third order system, then it will be s2 for sure. Okay? If it is a first order system, then it is s of x. Idea is clear? Now because we are doing the second order application, now here I am taking s square xi. Now s square कहाँ से है? Two orders ना? It is represented as two orders ना? So if x is the displacement, what is s of x? Velocity. What is s square x? Acceleration. ठीक है ना? So input acceleration. Now acceleration in the absolute form. ABS stands for absolute, right? Take it from my reference. Okay. Okay. So absolute information, absolute form of acceleration is the input. Relative form of displacement is the output. This is something I want. Now I can get it, but for that I need to modify this state. Okay. अभी जब तक तुमने modify किया, remember one more thing we have been already discussed. It doesn't matter whatever your equation है, always bring the highest order of coefficient as 1. We discussed a number of times whenever we do some mathematical calculations. So what is the highest order here now? S square. Remodify equation in a further so that this coefficient should be 1. Just bring it here. Okay? Do these calculations. You can do. So now by doing that, can I get this equation? 1 upon s square plus b by m into s plus a by m. Right? Can I compare it with the second order equation? S square plus twice zeta omega n s plus omega n square is equal to 0. Can I compare? So if I compare with the second order standard Laplacian equation, what will you get? Twice zeta omega n is equal to b by m. Omega n square is equal to k by m. K is known to you or not? Known. M is known to you or not? Right? Okay? Either operating frequency is given, you are asked to, you need to find some value, or M, K and B, all three should be known. Okay? So अभी omega n square is equal to k by m. यहाँ से मेरे को अपना operating frequency मिल जाएगा. At what frequency this device can operate? Can I get it? Once I get that value, can I get the value of zeta? Can I calculate? Twice zeta omega n is equal to b by m. Omega n is already known. Can I get the value of zeta? Zeta मिलने से क्या होगा? हाँ? क्यों zeta calculate करना है? Because I need to calculate damping factor to know whether the system will be remain underdamped or not. Because underdamped is the only system which is controllable. Who will control? Who will control? You people will control. है ना? उसे तुमसे सुपीरियर तो नहीं. Till the time mathematical modeling follow करोगे तो नहीं होगा. अब जो उल्टा सीधा AI घुसा रहा है भगवान जाने क्या होगा. ठीक है? Done. So now natural frequency is known. Zeta is known. If there is some miscalculation, you see that no, zeta is fine, but it's not perfect. There could be a sort of improvement. Then what you will do? Redesign. Because you need to ultimately change the value of m, k and b. Okay? Once you got the satisfactory zone, you fix it. Once you fix it, then you can go for mass production or not. Okay? So we will continue this discussion in the next class. Remember, this is one of the real life scenario of the case study, and these IC numbers you can check. There are two options available. One is Allen Bradley ADXL series, ADXL 150, 211, No, not 211. It's 210 or ADXL 250 or ADXL 311, where the highest digit indicates that in how many dimension you can measure the acceleration at the same time. So 150 means you are capturing data from a particular direction, one direction. 2 series means two directions. 3 series means three directions. X, Y. Okay? Or you can have similar solutions like from National Instruments, and its IC number is 9234, NI 9234. Both works the same. Okay? So we are studying as a case study of that particular sensor. We will discuss it further. Thank you.